Till now, we have understood how conversion works between binary and decimal. In fact, we have covered conversion between any number system to any other number system. Like we have seen examples of hexadecimal to binary and binary to hexadecimal. We have seen examples of decimal to hexadecimal, decimal to binary. We have covered everything, right? We have understood how conversion works from one number system to another number system. Now let's look at the operations. The most famous ones are addition and subtraction. So let's try to understand how do we add two numbers in decimal number system. Let's say these are the two numbers that we want to add, like 286 and 129. So I write them like this, right? Unit place, tens place, hundred place, correct? If I add 6 and 9, I get 15. But remember, we are talking about decimal number system. The numbers that you have are 0 to 9 only. These are the only 10 numbers allowed at any particular place. Let it be a unit place or tens place, anywhere. But this 15 is not in the range of 0 to 9. So what can we do with this 15? Well, 15 can be written as 1 into 10 to the power 1 plus 5 into 10 to the power 0. If you observe carefully, okay, this is the unit place and this is the tens place, right? That's why you have 10 to the power 1. That means this 1 can be transferred to tens place and value will still remain intact. That's what we are going to do. We are just going to keep 5 here and transfer this 1 to the tens place. You get my point? So 6 plus 9 is going to be 5 and 1 is going to be on tens place. 6 plus 9 should have been 15. But we cannot write 15 on any place because we are talking about decimal number system where we have numbers between 0 to 9 only. Now if we add 1 plus 8 plus 2, it's going to be 11. Again the same problem. We can only have numbers between 0 to 9. That's why you need to move this 1 to the very next place. Now 11 is already at tens place, correct? So this number can be represented as 1 into 10 to the power 2 plus 1 into 10 to the power 1. Remember 11 is already at tens place. So 11 into 10. 11 at tens place is going to be 110. Now this 110 can be represented as 1 into 10 to the power 2 plus 1 into 10 to the power 1. This one can go to the tens place, no problem. But this one can go to the 100 place because it is getting multiplied by 10 to the power 2. Makes sense, right? So now you have 1 passed to 100 place, that is the next place. So 1, 2 and 1, we have 4 finally. That's why the sum is 415. I hope that you understood the concept of carry. This value 1 and this value 1 are referred as carry. Now we have seen why this carry is important and how did we arrive at this method, that passing 1 to the next place, right? In binary number system also we are going to do the exact same thing, just the base is going to change. For example, let's say I want to add 0 110 plus 0 111. So I'm just going to write it like this. We have here unit place, that is first place, then we have second place, then we have third place. Now if you add 0 and 1, you get 1, no problem. When you add 1 plus 1, you get 2. Now here is the problem. We are talking about the binary number system. Then you can have only two possible combinations at any particular place, that is 0 or 1. Now this 2 is not in 0 or 1, right? So we cannot have 2 here. So what we can do? See, what does this 2 represents actually? It represents 2 into 2 to the power 1, correct? This 1 comes from the place and this 2 is a base. So rather than writing something like this at this particular place, what we can do, we can multiply this and you can write 2 to the power 2 into 1 plus 0 into 2 to the power 1. We can write it like this. Makes sense, right? This 0 into 2 to the power 1 is just going to be 0. Is going to be 0. And we have 1 into 2 to the power 2. This 2 into 2 to the power 1, we multiplied and we got 1 into 2 to the power 2. That means 2 at this particular place can be moved to the very next place and the value is going to be 1. This is the value, right? This is the base and this is going to be the position. correct? That's why you get 1 to the very next position, and you get 0 here, right? You see this 0? Makes sense, right? So we converted this particular value to this value, and because we are able to write it something like this, we managed to move our 1 to the next position. And why do we need to do this? Because you have 1 plus 1, 2. 2 cannot be placed at any position. Why? Because we are talking about binary number system. You can have 0 and 1, nothing other than that. So this 2 is not allowed here. So we converted this 2, which is 2 into 2 to the power 1. We converted this 2 into 2 to the power 1 into something like this. So now our 1 is right over here. Now you do the addition. 1 plus 1 plus 1 is going to be 3. Now 3 is also not allowed at any particular position. Why? Because 0 and 1 are the only two values allowed at any particular position in binary number system. Now this 3 actually represents 3 into 2 to the power 2. Correct? Now what I am going to do, I am going to write this 3 as 1 plus 2 into 2 to the power 2. Now I can write 2 into 2 to the power 2 plus 1 into 2 to the power 2. Now this 2 into 2 to the power 2 will become 1 into 2 to the power 3 plus 1 into 2 to the power 2. These values are exactly same. I can write 3 into 2 to the power 2 as 1 into 2 to the power 3 plus 1 into 2 to the power 2. Am I right? I can write it like this, correct? Look at this journey that we took. We divided 3 into two different sections, 1 and 2. Then we multiplied this 2 to the power 2 to 1 and 2 to the power 2 to 2. We got something like this, right? We converted this into this. So 1 into 2 to the power 3 and 1 into 2 to the power 2. This 1 will go here, second position. This is 0th position, this is first position, this is second position. That's why you have 2 to the power 2. So this 1 will go here, and this one will go to the very next position as a carry. Makes sense, right? So now you have 1 0 0, you add it and you get 1. So the final answer is going to be 1 1 0 1. I hope that you have understood the binary number system addition. It's exactly like decimal number system, just the base is going to change. Take one or two different examples and try to do it on your own. You will understand with more clarity. Now let's move forward. Now let's talk about the subtraction. Again, we are going to follow the exact same approach. We will first discuss the subtraction in decimal number system. Let's say I want to subtract 286 from 189. Answer should be 97, but it's not very straightforward. Let's say you have 7 objects. 1, 2. Let's say you have these 6 objects. And what subtraction tells us to do? It tells us to take away 9 objects from the 6 object. Is it even possible? If I ask you to take 2 objects from these 6 objects, you will take these 2 and remaining you will have 4, right? That's what 6 minus 2 is, right? 4. But what they are asking us to do, you have the 6 objects here with you. These are the 6 objects and they are telling you to take 9 from it. Is it even possible? No, it's not possible. So 6 minus 9 is not possible. So what we are going to do? Well, we need to help this 6, right? We need to increase this 6 somehow. This 8 right here can help on that. So this 8 will become 7. You take 1 from this particular 8 and you move it to unit place. 1 at 10's place is going to be 1 into 10 to the power 1. And this can be written as 10 into 10 to the power 0. So this 10 will go here. Now you have 10, which you got it from the 8, and you already have 6. So total is going to be 16. So 16 minus 9 is going to be 7. We took 1 from 8. That's why 8 has become 7 now. Again the same problem. You cannot take away 8 objects from 7 objects. So you need help. So who is going to help you? Well, this 2 is going to help you. This 2 will provide 1 to this particular 7. Now 1 at 100 place is going to be something like this. When you move it to 10's place, it will look something like this. So that's why you will have 10 more here. So 10 plus 7 is going to be 17. Now you can take 8 objects from 17 and the value is going to be 9. Again, it was 2 earlier, but it provided one value to 7. That's why it will become 1. So 1 minus 1 will become 0. That's how the subtraction works in decimal number system. And we are going to apply the exact same thing in binary number system, just the base is going to change. Very easy. You have something like this. You need to subtract 0 1 from 1010, right? Answer should be 11. And we are going to look into that. So this is the first position that we will have. We need to subtract this 1000 from 1010. Makes sense, right? Now look at this 0 and look at this 1. You cannot take 1 from 0. So this 0 actually needs help. Who is going to provide the value? The 1 from here is going to provide a value. 1 at this particular location is something like this. I can write it like 2 into 2 to the power 0. 2 to the power 0 means it's talking about this particular position, right? We are calling it as a 0th position, we are calling it as a first position, then we have the second position, then we have the third position. So you take 1 from the first position and then you send it to the 0th position, it will become 2. And we already saw how. 1 here has a value equal to 1 into 2 to the power 1. I can write this exact same thing as 2 into 2 to the power 0. 2 to the power 0 means the 0th position and value is 2. That's why this 1 became 2 once it moved from first position to 0th position. Okay, now you can take away 1 from these 2 and the value is going to be 1. That's very good. But because you sent out value 1 to this location or this position, you will have 0 here now. So this is the updated number now, 1002, and we took 1 from this particular 2 and we got this 1 value here. Okay, nice. Again we encounter the same problem. We need to take away 1 from this 0. Who is going to help it? This particular place should help it, but this place also has 0. So this place should help them, right? 1 at this particular position has a value of 1 into 2 to the power 3. This can be written as 2 into 2 to the power 4. So when you take 1 from here, it will become 2 at this particular location. Makes sense, right? Now you have 0 because you sent 1 here. When you send 1 from this third position to second position, remember we are calling it as a 0th position, we are calling it as the first position, we are calling it as a second position, and this is the third position. So when you send 1 from third position to the second position, it will become 2. But this doesn't solve our problem. Our problem was taking away this 1 from this 0. This 0 asks for the help of its neighbor 0, but it has no value. So we took from another neighbor, right? So this 1 got transformed into 2 at this particular location. Now this 2 is going to provide one value to this location. Now 2 here has value of 2 into 2 to the power 2. We are going to take away 1. So the value of 1 at this particular location is going to be 1 into 2 to the power 2. This I can write it as 2 into 2 to the power 1. So 1 at this particular location can be converted to 2 if we transform to the right side, right? So now we have 2 here. Because we are taking 1 from the second position, we will have 1 remaining. So 2 minus 1 is going to be 1. So now you have 2 here, you have 1 here, and you have 0 here. Now 2 minus 1 is going to be 1. This 1 minus 1 is going to be 0. And this 0 minus 0 is going to be 0. After doing this subtraction, now we have the final solution with us. So I want you to take the different examples and try to do it on your own. Take various examples so that you can understand it better. Once you understand the subtraction and addition in decimal number system, it is very easy to do in any number system, right? Binary is just the example that we took. You can do the exact same thing in hexadecimal number system also because it follows the exact same rules, just the base is going to be 16.